Today, we're going to be taking notes on speed graphs. For these notes, you're going to need the graph paper and 4 colors. So we'll start off by writing a title at the top of our page. We're going to write speed graphs and do it in all capital letters. They're referred to as speed graphs because you can use the information on the graph to calculate speed. In parentheses, in lowercase letters, we're going to write can calculate speed. Can calculate speed. We'll also add the formula speed equals distance divided by time. In class, I'm going to refer to these as distance graphs, and the reason I'm going to do that is because distance is what's written on the y-axis. So in all capital letters, I'm going to write distance graphs. Sometimes you'll see them referred to by other names. So in parentheses underneath distance graphs, I'm going to write displacement, comma, position. On my y-axis, I'm going to write in all capital letters, distance. These notes are going to look remarkably like your acceleration notes. So because of that, I'm going to add a little bit of color to make this easier to detect. So I'm going to add some little arrows here. I'm going to add some color. I'll put some stars by distance down here on my y-axis. Come back up here and add a little more color. I want these to really stand out because, as I said, you're going to have a lot of notes that look pretty confusing if you're not careful. On my x-axis, I'm going to write time. All of our graphs will have time on the x-axis. Now, I told you that you could use the formula to calculate speed, so let's give that a try. Speed equals distance divided by time. I do want you to write this on your notes because when you need a reference, this is going to be super helpful to you. Now, you'll notice that the 2 is on our x-axis and the 3 is on the y. Well, our x-axis is time. So I'm going to put a tiny t above my 2 because 2 is time. The 3 is my distance. So I can plug that into my formula. Speed equals a distance of 3 divided by 2. If you divide that out, what's half of 3? Well, that equals a speed of 1.5. Let's do it again for this one right here. If I put 6 over 4 and I divided that out, it's going to be 1.5. Okay, we'll try again. 9 over 6, if I divide that out, I get 1.5. My speed isn't changing on my first 3 dots. That's going to be kind of important. Over here at 0, 0, I want you to write started at home. I'm going to put home in quotation marks because home may actually be your literal home, or it may be a position in a room. It could be home plate if you're playing baseball. It could be any location that you're starting from. My first 3 points, we decided that the speed was 1.5. Well, I'm going to connect these points real quick. And I've got a nice straight line here. This is a constant speed. It happens to be a speed of 1.5, but we're not going to list that. You just need to know that it is a constant speed. When I look at my next segment, well, let's see. 5, my distance is 9, At 7, my distance is 9. At 9, my distance is 9. My distance isn't changing even though time is passing. Since my distance isn't changing, I'm stopped. So I'm going to draw a line. I am drawing my line just a little bit above the line on the paper so that I can see it more clearly. And I will write stopped. The next segment, if you notice, time increases and speed increases. I could plug these 3 points into the formula, but I don't really need that for today. I was just kind of proving a point on the last one. We're going to do this right here. Once again, this is constant speed. But what if this object, whatever this object is going faster? How would that graph change? I'm going to put a dot down here at 4 and 0, or 0, 4. Then I'm going to put a dot at 3, 5. What has happened here is we have gone a long distance of 3 meters in just 1 second. If you cover a lot of distance in a short time, that is a fast speed. So we're going to say faster right here. Now the opposite of that, if I covered a large amount of time and I went to 1-7, if I covered 3 seconds here, but I only got 1 meter in distance, that is going to be slower. So the slope of the line tells you how fast or slow something is going. I'm going to put some notes down here at the bottom of the page. Constant speed dash diagonal line. And stopped dash flat line. So my two colors, I'm going to underline constant speed down here in my first color. And I'm going to color the line for constant speed and color this line for constant speed. Then I'm going to go down here and I'm going to underline stopped and I'm going to color stopped this color. So far, every time this object is moved, it is moved further away from the home base. Let's make a mark at 14 seconds, which is the halfway point up here at the top. I'm going to draw a bracket right here and write moving away from home. Moving away from home. In one of my other colors, in my third color, I'm going to underline away. And I want to put dots under the constant speed as the object is moving away from home. I'm going to put some dots over here too. Don't go up too high because you've got some other things you're going to write there and it'll get in the way. Okay, one of the things that people get confused about on this graph is they think that my object has gone up a hill. Then it sat on the hill and then it went further up a hill. This is not a hill. It does not have anything at all to do with hills, okay? We'll just pretend like my object is here in Lubbock, so therefore there are no hills. It's not going up, it's not going down, okay? Know that this is not anything to do with altitude. So we were at a distance of 13 right here. Then we're coming to a distance of 10. Then we're coming to a distance of 7. And we're coming to a distance of 4. So this is actually moving the same direction. It's a flat diagonal line, so it's going to continue to be constant speed. It's just headed back toward home. So I'm going to go ahead and put in this line. And above it, I'm going to write constant speed. And I can color that in my constant speed color. Now, my distance is 4. And if I move over a little bit, if more time passes, 2 seconds later, I'm still at 4. I'm still at 4. That means that the object is stopped. So drawing a line again, once again, just a tiny bit above what's written on the paper so that I can see it better. And I will write stopped. Once again, I'm going to underline in my stopped color. The last section, once again, is getting closer and closer toward home. It is also a constant speed. I'll write constant. And I will draw that in. Okay, we've got to the very bottom. This is stopped, but it is stopped at a very specific place. It is stopped at home. It is stopped at this 0 point back at home. I am going to take my stopped color and color that, and the fact that it's at home is so important that I'm going to I'm going to put a little cloud around it. I'm going to put a little cloud around it over here also, okay? Home is your 0 point. That is where you started, and so when you stop there on that bottom line, it means that you have returned home. One last notation that we need to make on here, or set of notations, we're going to do another set of brackets up at the top. And we're going to write moving toward home. And I'm going to use my final color here, underline toward home. And then I'm going to put dots above. I'm going to put dots above the areas where we are headed back toward home. Once again, please remember, this has nothing to do with altitude. It has nothing at all to do with whether or not they're going up and down hills. It's just showing you the information that you need to calculate speed and the displacement from its original position. Thank you.